triangle ABC is shown. Given that triangle ABC is isosceles, point D is the midpoint of AC. We want to prove that angle BAC is congruent to angle BCA. Place reasons in the table to complete the proof. So they've already started a proof for us, and we just need to be able to fill in these last three blanks. We want to start from the beginning though. We want to see if we can determine what this proof is really meaning. And so it says triangle ABC is isosceles, D is the midpoint of AC, and that's given. Okay, then that means that AD is congruent to DC. So if we want to mark that up here, we can. Remember, you have scrap paper, and of course exam, make sure you use that. That is the definition of a midpoint. So since D is in the middle, we do know that those two segments are congruent. BA is congruent to BC. That's already marked up here. I guess I could have it 2 since I already used one down below. But that is definition of isosceles triangle. We know that those two sides would be the same length. BD exists. So through any 2 points there is a line, and so if we wanted, that's not a straight line, it should be, but if we wanted to draw a line, we can. BD is congruent to BD. We know that because anything's congruent to itself, and that is considered the reflexive property. So the reflexive property is whenever you have something and it is congruent to itself. A lot of times you see this when you are having or finding congruent triangles. Anytime that you have figures that are drawn together, if they share a side, we know that that is congruent to itself. Now, triangle ABD is congruent to triangle CBD. If you take a look at this, all of their side lengths are the same, and so that would be side, side, side. Angle BAC is congruent to BCA. Almost any time after you've already found that your triangles are congruent, if there's where you have the parts of the triangles, then that is where we had CPCTC, which I'm going to abbreviate, but CPCTC is kind of how we abbreviate it in class. It means corresponding parts of congruent triangles are congruent. So if we know that these triangles are congruent, one of the definitions of congruent triangles is that it also has congruent angles. So therefore, we can prove that this angle is congruent to this angle. Some of the other things, AA congruence postulate, that doesn't actually exist. We did have AA, but that had to do with similar figures. SAS is a postulate or property to be able to say that we have congruent triangles. However, they didn't tell us anything with our angles within the part of the proof that they've given us, so that's why we couldn't use it here. Symmetric property is saying that something is congruent, but like, for example, if you know that A is equal to B, then you know that B is equal to A. It's where you switch the order and they're still equal on both sides. And then the midpoint theorem just tells us that we have, if it's a midpoint, we use the definition of midpoint already, but we were kind of away from there when it came to filling in our blanks. So that's just a little bit of a description of what some of these other ones are, though, because depending on what proof you have, they could be important as well. If you have any questions, please let me know.